Hi guys, we've got an applications of differentiation question here today where it's asking us to find the equations of the tangent and normal to the curve with equation f of x equals x bracket 3 minus x all squared at the point 2, comma 2. Okay, so first of all we have to figure out what, let's just define what these tangents and normals mean. So basically what we've got here is if we have a curve, let's just say it looks like this, and we're looking for a tangent at a particular point, let's say here, that's going to be equal to some sort of line that just brushes the curve at a particular point where the gradient of the tangent and the gradient of the curve are equal. Now the normal to the curve at that point is a line that basically is at perpendicular to the tangent. So this is going to be a 90 degrees. Sorry about the crapness of my drawing. Basically what it is, it's a perpendicular line to the tangent of the curve. So the gradient of the normal is the negative reciprocal of the gradient of the tangent, but we'll get to that later. So let's just get rid of this, make it a bit neater. Okay, so let's go about solving this problem. So what we're going to do first, for me, what I want to do is, so we're going to have to find the derivative of this function. But to start with, what I'm going to do is I'm going to expand this bracket just to make the derivative process easier. So we've got the function of x is equal to, now we've got x bracket, now this is going to be 9 minus 6x plus x squared, which if we multiply out that bracket and do a bit of rearranging, we have x cubed minus 6x squared plus 9x. So there's our function once we've multiplied out the bracket. Now what we have to do is we're going to have to get the derivative of this so we can find the gradient of our tangent line. So we're going to find the derivative. So we've got f dash of x. And that's going to be equal to 3x squared minus 12x plus 9. Okay, now we have to figure out what the gradient of this function is at the point x, when x equals 2. So what we're going to do is we're going to go f dash of 2, and that's equal to 3 times 2 squared minus 12 times 2 plus 9. Cool. So 4 times 3 is 12, minus 24 is negative 12, plus 9 is negative 3. So our tangent line, which takes the form, the equation of our tangent takes the form y equals mx plus c, we know that our m of this function is going to be negative 3. So let's plug that in. So we have y equals negative 3x plus c. Cool. Now we also know that this tangent line goes through the point 2, comma 2. So what we're going to do is we're going to sub in these 2 points and we'll be able to solve for c. So we know that 2 is equal to negative 3 times 2 plus c. So this is going to be negative 6. If I take it over the other side, it's plus 6. So 2 plus 6 is 8. So c will equal 8. So the equation of our tangent line is y equals negative 3x plus 8. Cool. Now we have to find the equation of our normal. So, like I just explained before, the normal has a gradient that is perpendicular, that makes it perpendicular to the tangent line. So hopefully remembering back in your maths that you'll know that if we have two lines that are perpendicular to each other, we know if we take the product of their gradients, they equal -1. So we know what M1 is, so to figure out what M2 is, we can just say M2 which is equal to -1 over -3, which is 1/3. Cool. So our normal is also going to take the gradient, the function is also going to take this form. So let's just write that in. So we're also going to have y equals mx plus c. And we now know what the m's going to be. It's going to be 1/3. So we know that y is going to be equal to x divided by 3 plus c. And like the tangent line, the normal also passes through this point, 2, 2. So we just substitute these 2 points in. So we have 2 equals 2 over 3 plus c. So if we take that over to the other side, it's going to be c is going to be equal to 4 over 3. Therefore, we can say that the normal is going to be y equals x plus 4 all divided by 3. Cool. So basically what we have to do with these equations, to find the tangent to the curve, first of all, we get our formula into a point where you feel comfortable doing the derivative of it. I like to multiply out the brackets so I don't have to use the product rule or the chain rule. We then take the derivative of it and we find out what the gradient of the function is using the derivative at the point that they ask us. We do that to try to find the gradient of the tangent line, i.e. this little bugger here. Once we've found that, we then substitute it in. We then substitute in our x and y coordinates of our point that they've given us, and we solve for c, and then we have our tangent line. For the normal to the curve, it's exactly the same, except rather than taking the derivative to find the gradient, we use the fact that the two lines are perpendicular to each other, and then we know that if we take the product of two perpendicular gradients, they equal -1, to solve for the second gradient. We then substitute in our points from our x and y coordinate from our point, solve for c again, exactly the same as this one, and we get our normal equation as well. So it's not too complicated. There are some definite steps there. I hope this video helped. If it did, give it a like. Subscribe to my little channel here. I post new videos as often as I can. But until next time, I'll catch you later.